Again, most of these concepts we have already looked at much before. Here, many of the same concepts is being repeated at a much more formal level with some proofs, additional proofs. So treat this particular session as a kind of a summary with a little bit more insight. F of x tends to positive infinity as x tends to a means 1, that is f of x is greater than 0 near a, right, not equal to a. Near a it is going to be positive. And the second is that limit as x approaches a of 1 by f of x. Remember, we can think of it as 1 by infinity, which is equal to 0. So we write this as limit as x approaches a of f of x is equal to plus infinity. So try to understand it and internalize it, because this is really going to be very useful in problem solving. So we say f of x tends to positive infinity as x approaches a, and when we say that, we mean that f of x is greater than 0 and the limit of its reciprocal is equal to 0. Okay, similarly, let's look at the second one. Now when we say f of x tends to minus infinity as x approaches a, means f of x is less than 0 near a, not equal to a, and the limit as x approaches a of 1 by f of x is equal to 0, and we write it as limit as x approaches a of f of x is equal to minus infinity. Okay, remember tan, graph of tan, so it goes towards infinity as it gets closer to pi by 2, as theta gets closer to pi by 2. Tan theta goes towards plus infinity, and when we look at on the negative side, that is minus pi by 2, it goes towards minus infinity. Okay, so now these, what we looked at till now, these limits are called infinite limits. Now let's look at another aspect, that is limits at infinity. Here the difference is what? Here x was approaching a. Now we are going to say, look at when x approaches infinity. So when we say f of x tends to a limit as x approaches positive infinity, that means x becomes larger and larger and larger. What we mean by that is f of x is defined near positive infinity. That means for all x greater than k belonging to the set of positive real numbers. And the second aspect is that the limit as t approaches 0 from the positive side, f of 1 by t is equal to L. Remember, as t approaches 0 from the positive side, 1 by 0 would become infinite. Okay, so as t approaches 0 from the positive side, f of 1 by 2 will be equal to the limit. This we write it as limit as x approaches positive infinity of f of x is equal to L. Okay, fourth one. Now when we say f of x approaches a limit as x approaches minus infinity, what we mean is f of x is defined near minus infinity. That is, for all x less than k belonging to the set of negative real numbers. And the second is that limit as t approaches 0 from the negative side, from the left hand side, of f of 1 by t is equal to limit L. So we write this as x approaches minus infinity of f of x is equal to L. So this is the limit at negative infinity. This is limit at positive infinity. This is a limit which goes to infinity, negative infinity, and this is a limit which goes to positive infinity. Okay, let's look at another aspect. If both limits, that is positive infinity and negative infinity, they both exists, we say, or we write it like limit as x approaches infinity of f of x. We don't say plus or minus. We don't say plus infinity, minus infinity. We just say limit as x approaches infinity of f of x equal to L, which basically means limit as t approaches 0 of f of 1 by t is equal to L. They both mean the same thing. Okay, so this is tricky. You should be able to do curve tracing in your mind and figure out these aspects. A small session. Bye for now.